Hello everyone, today I'm going to discuss the topic integration. So here we have the volume of a solid of revolution. Volume of solid generated by revolving the region bounded by a curve and x or y axis. In this section, we use the integrations to calculate the volume of a solid, considering the solid of the revolution in the following figures, which are formed by revolving certain region about an axis. So kindly focus on the first diagram on the left hand side. Given the situation is a constant line, if we're revolving about the x-axis, and they will form a cylinder, which is on my right. Next, we're going to have the second situation. Given the function is a linear function, if the situation is revolving about the y-axis, and it will form a cone, which is on my right. Next, we're having a situation, a curve is given. If the curve is revolving about the x-axis, then it will form a shape of oval on the right. Here we have the situation, revolve about the y-axis. The volume of the solid generated by revolving the region about the y-axis between the graph of the continuous function, where we have the function x is equals to fy, and the y-axis from the value c to d. The formula given will be v is equals to pi multiplied with integrate x squared with respect to y for the limit c to d. Or we can express the situation pi multiplied with integrate, substitute the function x, which is fy, into the situation square with respect to y from the limit c to d. Here we have the example for the volume. The curve y equals to square root of x, the line y equals to 2, and the y-axis from the side of a bounded region R. Find the volume of the solid generated by revolving the R about the y-axis. So first is to sketch the graph. So here we have y equals to square root of x. So the graph will be like this. Next, the line y equals to 2. So here we have y is equals to 2. Next, we have the y-axis. Form the side of the bounded region R. So where is the region R? So the region R will be here. So meaning that we will have the value 0 until 2. Next, find the volume of the solid generated by revolving R about the y-axis. So here we name it as R. Next, find the volume of the solid generated by revolving R about the y-axis. So meaning that we are going to revolve about the y-axis. V is equals to pi multiplied with integrate, where we have x squared with respect to y. So kindly refers to the situation x squared. So meaning that we have to modify the situation. Y is equals to square root of x. So x will be equals to y squared. So kindly form the situation. Volume is equals to pi integrate, where we have x squared. So the x is equals to y squared. So we will have y to the power of 4 with respect to y for the limit 0 to 2. Kindly integrate the situation. Y to the power of 5 over 5 for the limit to 0. Multiply with the pi. If we substitute the situation, and we will have volume is equals to pi multiplied with 32 over 5 minus 0. If we simplify the situation, and we will have volume is equals to 32 pi over 5 unit cube. So here we are, and thanks for watching.